Okay. So, okay, non-parametric, okay, the Wilcoxon rank sum is actually the non-parametric test for the two independent sample. Okay, in parametric we have two independent, we have t-test, okay, for two independent sample. So if you cannot proceed with the t-test, okay, we have the alternative by using the Wilcoxon rank sum. Okay, in Wilcoxon rank sum, we will test the two distribution, whether these two distribution is the same, is identical or not. Okay, so our H null will be our we can write our H null as the Fy equal to Fx. Okay, the distribution of y is equal to the distribution of x against the alternative Fy is equal to Fx x minus theta. It means that y and x have the same distribution except that the location of the distribution is differ. Okay, in non-parametric normally we will use the median. Okay, so we will test whether the median of these two population is different, is the same or different. Okay, so Fy, okay, Fyx is actually equal to probability of y less than or equal to x equal to probability of, okay, we see that x and y has the same distribution except for the location. Okay, so we can write as x plus theta less than or equal to x. So we will have px less than or equal to x minus theta. So we will have fx x minus theta. Okay, so y and x have the same distribution, okay, same shape and everything except for the location. Okay, so if theta, okay, if theta is equal to 0, what happen? Fyx equal to fx. Okay, fy equal to fx when theta is equal to 0. Okay, so means that the two distribution are identical. Okay, x equal to y. Okay, when theta is positive, okay, when theta is positive, meaning that theta is greater than 0, what happen? Okay, your y is actually shift to the right of your x. Okay, so this is the x distribution, and y, okay, when theta is positive, y is actually shift to the right of x. Okay, so that we will have our median of x should be less than median of y. Okay, this is our alternative hypothesis. Okay, normally we can put as theta greater than 0 or mx less than my. Okay, the median of x is less than median of y. Okay, and the other case when your theta is less than 0. Okay, when your theta is less than 0 means that, okay, the distribution of y is shift to the left of x. Okay, this is your x distribution. So your y, okay, theta less than 0, your y distribution will shift to the left of your x. Okay, you can see that the two distributions are the same except for the location. Okay, so in this case our mx, okay, the median of the y, the median of the x will be greater than the median of the y. Okay, so we have these three alternative hypotheses. Okay, for the null hypothesis, we will use fy equal to fx. Okay, everything is the same like this. Okay, here. Okay, and our test statistic here based on Wn. Okay, Wn is the Wilcoxon rank sum, which is the rank sum of your x. Okay, and your x is your smaller sample. Okay, your x is the smaller sample. Okay, we look at this example. Okay, the bacteria per volume are shown in the table below for the two types of cultures A and B. So we have A and we have B here. Okay, 5 observations were made for A and 4 for culture B. Okay, we have 5 observations for the culture A and 4 observations for the culture B. Okay, we want to test the hypothesis that there is no difference in the population medians for the bacteria count. Okay, in this case, we will say that for the H null, okay, our H null is actually H null. What is our H null? mx is equal to my, or theta is equal to 0. Okay, there is no difference between x and y. Everything is the same. The shape of the distribution, the location of the distributions are the same. Okay, against the H1, okay, so we want to test there is no difference in the population medians, means that for the alternative hypothesis there is a difference in the population medians. So mx will be not equal to my, okay, or theta not equal to 0. Okay. Okay, so here what is your x, what is your y? Okay, x, okay, we will use our test statistic as wn. Okay, wn is the rank sum, okay, for the, okay, actually in these notes I have made some mistake, so I will tell you where is the mistake so that you can take note, okay, where is the mistake. Okay, so wn here is the rank sum for the x sample. Okay, so x sample, how do you want to determine where is your x sample, where is your y sample? Okay, normally for x sample, we will take the smaller sample. Okay, the smaller sample will be your x. Okay, so here what is your x? The culture B. Okay, and culture A will be your y. Okay, so here we will have our m equal to 4 and our n equal to 5. Okay, remember that we have derived the null distribution for wn. Okay, Wilcoxon rank sum, which is based on m equal which is based on m smaller than n. Okay, so in this case our m is equal to 4 and our n is equal to 5. Okay, so we have to calculate what is the wn. Okay, the procedure for the Wilcoxon rank sum, we can combine the two sample here. Okay, we combine these two sample and we give them a rank. Okay, we give them a rank. Okay, we combine these two. So when we combine these two, we give them a rank. So what is the observation which is rank number 1? Okay, observation with rank number 1 is here, right? Okay, 25. 25 is the smallest value. So this is rank number 1. Okay, and then rank number 2, 26. Okay, rank number 3. Okay, 27 here. Okay, rank number 4 is 28. Okay, rank number 5, 29. Okay, rank number 6 is 31. Okay, rank number 7, 32. Okay, rank number 8 is 33 and rank number 9 is 35. Okay, if you have a type observation, then you will apply the mid-rank method. Okay, you give a mid-rank method. So, we will count the rank sum for these two. Okay, what is the rank sum for these two? 7 plus 5 plus 9 plus 4 is equal to 25, right? Okay, and this one, 3 plus 6 plus 2 plus 1 plus 8 is equal to 20. Okay, so I have mentioned just now that I have made some mistake in these notes. Okay, actually the test statistic, okay, the test statistic wn is actually for the rank sum for the smaller sample. Okay, not the minimum between the rank sum of these two. Okay, actually the wn is the rank sum for the smaller sample. Okay, so make sure hopefully make sure that you you correct your lecture note. Actually I have upload the new one. Okay, I have replaced this. I have edit this one and upload the new one. Okay, you can refer to your Putra Blast to get the latest lecture notes. Okay, so wn is actually the rank sum for the smaller sample. So our smaller sample means that which sample has the smaller size. Okay, in this case, sample B has the smaller the smaller size because the size is 4. Okay, sample A, the size is 5. So we will choose the rank sum Wn as the rank sum for the smaller sample, which is B lah. Okay, sample B. So the rank sum is equal to 7 plus 5, okay, plus 9 plus 4. So equal to 25. Okay, so that is our test statistic. Okay, so what is your rejection region? Okay, since we have a two-tailed test, okay, because our alternative here is not equal, then we will have a two-tailed test. So you will reject H null. Okay, our rejection region will be reject H null if Wn okay, Wn is less than W alpha divided by 2 or Wn greater than or equal to W1 minus alpha divided by 2. Okay, actually here we will know that we can reject H null, okay, when we have a significantly small or large value of Wn, okay, because we have two-tailed test. Okay, it can be at the left side or it can be at the right side. Okay, because two-tailed we don't specify any direction of the differences. Okay, so for large value of Wn or small value of Wn will reject your H null. Okay, meaning that most of the X has large rank or most of the X has small rank. Okay, so that we will reject our H null here. Okay, so we have to compare our test statistic Wn here with the critical value from the Wilcoxon rank sum table. Okay, Wilcoxon rank sum table. I have uploaded the table. So this is the table for the Wilcoxon rank sum. Okay, we can find the value of M and value of N here. Okay, value of M. Our M is 4, right? Okay, our M is 4. Okay, our M is 4 and our N is 5. Okay, our N is 5. So M and 5. Okay, our alpha, we will test at alpha equal to 0.1, right? What is alpha? Okay, 0.1. Okay, we will test at 0.1. So divide by 2, 0.05. Okay, so you have to find the critical value where the probability is less than or equal to 0.05. So 0.05 is here. Okay, 0.05 is here. So the lower critical value is 12 and the upper critical value just at the right side here. Okay, because we have both left and right tail here. So we just look at the 0. Which is less than or equal to 0.05. So the closest is 0.032. You cannot take 0.056 because it is already exceed 0.05. So the closest to 0.05 is 0.032 here. Okay, so at the left side, okay, or at the left tail, okay, the critical value is 12 and at the right tail the critical value is 28. Okay, so 12 and 28. Okay, so here. Okay, reject. Okay, we reject H null if Wn is less than or equal to 12 or Wn is greater than or equal to 28. Okay, here the table here is actually the null distribution, okay, of the Wilcoxon rank sum. Okay, you can derive here. Okay, I already show you last week how to derive the null probability distribution of the Wn statistic. Okay, so this is the partial of that table. Okay, however, we have the Wilcoxon rank sum table, so we just refer to that table. Okay, so what is the decision here? You can compare our Wn is actually equal to 25. Okay, so we can see that. Okay, Okay, the right tail here, the critical value is 28, and at the left tail here, the critical value is 12. Okay, we know that Wn statistic has a symmetric distribution, right? Okay, so Wn equal to 25 is actually falls in the non-rejection region. Okay, this is our Wn. Falls in the non-rejection region, so do not reject H null. Okay, we fail to reject H null, so we don't have enough evidence to conclude that the two population medians are different. Okay, so we don't have enough evidence to conclude that the two population medians are different. Okay. Okay, any question? Can you understand this? Okay. Any question?
Oh, okay.
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 Okay, so we look at how we can construct the point, or how to get the point and the interval estimator for our Wn statistic. Okay. So if the population from which the X and Y samples, okay, are drawn are identical in every aspect, okay, no aspect except location. Okay, say that Fy equal to Fx, okay, x minus theta for all x and for some theta. Okay, it means that when your theta is equal to 0, then there is no difference between y and x. Everything is the same, okay, including the location. Okay, but if your theta is not equal to 0, then there is a difference between y and x in terms of the location. Okay, the shape of the distribution is the same. Okay, the location, only the location. Okay, when your y shift to the left or shift to the right of your x distribution. Okay, we see that the y population is the same as the x population, but shift by an amount theta. Okay, we wish to use the test procedure to find both the point estimate and confidence interval for theta. Okay. Okay, so how to construct the confidence interval and the point estimate for our Wn, okay, or our theta, our theta, okay, our theta, not Wn, okay, our theta. Okay, so we arrange the Mn differences, okay, Dij. Okay, in this case, we will use Yj minus Xi. Okay, we will use this as our differences. Okay, we arrange these differences in magnitude from the smallest to largest. Okay, so we order from smallest to largest, denoted by D1 until Dmn. Okay, so if you have m equal to 4, n equal to 5 observation, then you will have 20 differences. Okay, 4 times 5, 20 differences. Okay, then the theta hat, okay, the point estimate of theta hat is actually the median of dj, okay, the median of the differences. Okay, and the confidence interval for theta is given by this, okay, dmn plus 1 minus k and dk. So what is k? K is actually Wn max, okay, maximum of Wn minus W alpha divided by 2. You can find this from the Wilcoxon rank sum table plus 1. Okay, so the lower is given by Dmn plus 1 minus k. So you have find the order, okay, the order of these differences, okay, from this magnitude, okay, from smallest to largest, okay, from this Dij. Okay, and dk is the upper limit. Okay, this is the lower limit and this is the upper limit. Okay. Okay, so we want to construct the confidence interval for this example. Okay, the bacteria per unit volume are shown in the table below. For two types of cultures, A and B, okay, 5 observations were made for A and 4 for culture B. Okay, so here, okay, the same example, but now we want to construct the confidence interval for the difference of the two population medians. Okay, 90%. Okay, so first we have to arrange, okay, or not, we have to get the differences between yi and xj. Okay, yj and xi, sorry, yj and xi. Okay, so dij equal to yj minus xi. You get these differences. Okay, so here, what is your x, what is your y? Okay, x will be the smaller sample. Okay, x is the smaller sample, so x is actually our sample B. Okay, y is our sample A. Okay, because sample B consists of 4 observation and sample A consists of 5 observations. So here will be our M equal to 4 and this one our N equal to 5. Okay, so we need to get the differences. Okay, here. Okay, so the differences here. Okay, let's say we have A 27, 31, 26, 25, 33. Okay, and then 32, 29, 35, 28. Okay, so you get the differences. Okay, so this is our x and this is our y. Okay, so y minus x. So 27 minus 32 minus 5. Okay, we will get negative 5. 27 minus 29 is negative 2. Okay, you will do this until the end of the observation here. 33 minus 28 equal to 5. Okay, so once you get these differences, we denote as dij. You have to sort this dij in increasing order. Okay, so start from smallest until largest. So the smallest of the dij here is minus 10. Okay, so minus 10. Okay, the next smallest is minus 9. Okay, so you have sort this. Okay, from smallest to largest. Okay, so you will, we will get this. Okay, so how many differences? Okay, mn. So m equal to 4, n equal to 5. So we will have 20 differences. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 times 4 is 20. Okay, we will get 20 differences. Okay, and then you have to find your k. Okay, what is k? K is the, what is k? K is the Wn max minus W alpha divided by 2 plus 1. Okay, Wn max. What is the Wn max? Okay, Wn max. What is the formula for Wn max? Is equal to M 2N minus M plus 1 divided by 2. Okay, capital N here is actually your M plus N. Okay, M plus N. So we will have M is equal to 4. Okay, 2, our N. What is our N? M plus N, 4 plus 5 equal to 9 times 2 is 18. Okay, 18 minus 4 plus 1 divided by 2. Okay, so this is equal to 30, right? 18, 14, 15. 4, 60 divided by 2. So 30. Okay, you will get 30 for the Wn max. Okay, and then we can substitute in here. Wn max is 30 minus, okay, W alpha divided by 2. We want to construct a confidence interval for the 90%. So when we use 90%, actually alpha equal to 0.1. So our alpha divided by 2 is actually 0.05. Okay, so you have to find from the Wilcoxon rank sum table, okay, to get this critical value, okay, to get the W alpha divided by 2. Okay, so W 0.05. Okay, we already look at this table just now. Okay, never mind, I will show it again. Okay, here, okay, our M is equal to 4 and our N is equal to 5. So you have to find the value which is close to 0.05. Okay, so here 0.032. Okay, so the critical value is actually equal to 12. Okay, equal to 12 here. Okay, so we will get this one equal to 12. Okay, so minus 12 plus 1. Okay, so this is actually equal to what? 9, 19. Okay, so the upper limit, okay, for our theta, okay, the upper limit is given by dk, right? Okay, dk, this is the upper limit. Okay, so dk, the position of the 19 position in these differences. Okay, so the 19 position is the value of the 19 position is 4. Okay, so 4 here. Okay, dk equal to 4. And then for the lower, okay, the lower is d. What is the formula for the lower? Mn plus 1 minus k, right? So equal to d. Mn is for 5, 20. 20 plus 1, 21. Minus k is 19. So equal to 2, right? Okay, the second position, okay, from this dij differences is minus 9. Okay, so we will get our theta is actually between minus 1 and 4. Okay, can you see that from this interval? Okay, how to interpret this interval? Okay, you can see that in this interval, there is a possibility that in this interval, zero value is included in this interval. So there is a possibility that your theta is equal to 0. Okay, when your theta equal to 0 means that there is no difference between the population medians. Okay. So this confidence interval actually support the conclusion that you obtain from the hypothesis testing, okay, that we have conduct just now, right? Okay, so you will get the similar conclusion. Okay, actually, we are not constructing the 90% confidence interval, because if you look at this table, okay, if you look at this table, it is actually give us the value 0.032. Okay, 0.032 is actually uh, 96.8. Okay, about 96.8. 0.032. Okay, 0.032 times 2. Okay, so minus 1. Okay, 93.6. Okay, we are actually constructing a 93.6 confidence interval. Okay, because here, okay, our probability here is 0.032. Okay, 0.032. Okay, for the one-sided. So for both-sided, it will be equal to 0.032 times 2 is 0.064. Okay, minus 1 is 0.936, so 93.6% confidence interval. Okay, 96.8. Alpha, wait our alpha, we okay, here this is actually 0.032. Okay, 0.032 times 2. Okay, 0.094 minus 1. Okay, actually we are constructing a 93.6%. Okay, 93.6% confidence interval. Okay, we just approximate, not 90%. Okay, so here, okay, we will get, okay, the theta value between minus 9 and 4. Okay, if you, let's say you already sort the sample A and sample B. Okay, let's say you sort in increasing order. You start with a 25, 26, and then, okay, like this. Okay, let's say we start with 25, and then 26, 27, 31, and 33. Here also you will start with the 29, not 29, 28, okay, 29, 32 and 35. So what do you expect to your confidence interval? Okay, what is the value for your confidence interval? What do you think? If you sort the data first and then you get the differences. What do you think? Anyone? What will be the value of the confidence interval? Your theta is between? Anyone? Here I'm not sort the value, the sample, okay, the sample A and the sample B. Let's say you sort the sample A and the sample B first and then you get the differences. Okay, what do you think about the theta value? Okay, the confidence interval for the theta. It will be -4 and 9. Okay, so dia akan it will be terbalik. Okay, upside down. Okay. Do you understand what I mean? Okay, so it will change. Okay, it will change. So here will be -4 and the other side is 9. Okay, you can try here. Okay, it's still either you want to sort the sample A and sample B first and then get the difference, or you don't want to sort, you just get the difference. The answer will be both answer are correct. Okay, only the value here like this. If you are not sort first, you will get minus theta between -9 and 4. But if you sort first, you will get -4 and 9. Okay, theta between -4 and 9. Okay, the theta hat, what is the theta hat here? Okay, it is the same whether you get this one or this one, is still you get the same conclusion where your theta value include 0. Okay, in the interval will include 0 value. Okay, so what is your theta hat? Theta hat is the median. Okay, the median of dij. Okay, so what is your theta hat here? Okay, so we have 20 observation. So theta hat will be d 20 divided by 2 plus d 20 divided by 2 plus 1 divided by 2. Okay, so d10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, minus 3 plus 11 is -2. Okay, divided by 2. So -5 divided by 2 is -2.5. Okay, so this is your point estimate of your theta. Okay, you can see that the point estimate of your theta is included within this interval. Okay, -4 and 9 or -9 and 4. Okay, the asymptotic relative efficiency. Okay, we will learn this ARE after the second half. Okay, of relative to T is never less than 0.6864, and if the populations are normal, the ARE is quite high at 3/pi. Okay, the Wilcoxon rank sum test performs better than t-test for some non-normal distribution. Of course, because for the t-test, the assumption is the sample come from the normal distribution. Okay, if the sample is not from the normal distribution, so the non-parametric test is has the um, is more perform. Okay, is more perform compared the parametric, which is the t-test. Okay, for example, the ARE is 1.5 for the double exponential distribution and 1.09 for the logistic distribution, which are both heavily tailed distribution. Okay, so here we will learn detail in the topic asymptotic relative efficiency. Okay, after the after the semester break. Okay. Okay, then is there any Anything left here? Oh, okay. So the last one, exercise. Okay, maybe we can do this exercise together before we take a break. Okay, so can you try to do this exercise first? I give you some time to do this, or you have done this before, or you already done this exercise. Not yet.
No, not yet.
No, yeah.
Okay, not yet. So you can try now. Okay, you can try now. So first, okay, find the null probability distribution of the statistic Wn. Okay, for m equal to 2 and n equal to 4. Okay, last week we already learned how to derive the null probability distribution for the Wn, right? Okay, so you have to you need to know what is the Wn minimum and then Wn maximum. Okay, since Wn is a symmetric, then you just get the upper half or the below half of the distribution of the probability. Okay, because the other half you can get it by symmetry. Okay, maybe you can try this one first. Wn minimum is equal to m is equal to 2 and n is equal to 4. So Wn minimum, anyone? Have you
3.
tried? Equal to 3. Wn max?
6.
11.
11. Okay, how do you get 6? 11, yes.
Maybe I apply different. Okay.
Because n, remember n is m plus
Sorry, yes, it is
n.
11. Yeah.
11. Okay, so n is
The
m plus
expected is 6. Yeah.
Okay, so and we know that Wn is symmetry at Wn
7.
At 7. Okay, okay, the formula is m n plus 1 divided by 2. Okay, so equal to, here we have 2, n is 6 plus 1, 7 divided by 2 is equal to 7. So we just need to get the upper half or below half of the Wn value. Okay, so means that you need to find the Wn from 3 until 11, and it is symmetric at 7. Okay, so we will have here our Wn. Okay, Wn is equal to K. Okay, from 3, 4, 5, 6, 7, 8, 9, and 11. Okay, no need to find the whole thing here, just half of them. Okay, whether you want to find half the below symmetry or above symmetry. Okay, which one you think is much easier? Okay, is easier. Okay, so I think maybe for the below symmetry lah. Okay, below mean. Okay, below mean is much easier because it is it is much easier to give a rank for your x. Okay, because the number is small here compared to this one. Okay, but you can find 7 to 11, doesn't matter, or you can find from 3 to 7. Okay, also can. Okay, so here is the rank. Okay, rank of our x. Okay, rank of x. Okay, this is rank of x. Okay, this is rank of x. So how many rank of x? Okay, here we have 6 observation, right? We can give rank 1, 2, 3, 4, 5, 6. Okay, so for rank of x, okay, rank of x only 2 observation. Okay, so 3, how can we assign how can we assign the rank for x? Okay, so that when you add that rank, it will give you a number equal to 3. Okay, so how to assign the rank for x? 1 and 2, right? Okay, why two rank only? Okay, because your x is 2 observation. Okay, so we can assign rank 1 and 2. Okay, 1, 2, so that when you add 1 plus 2, you will get 3. Okay, 4. How about 4? 1, 1, 3, right? Okay, so 5. Is there any other way to assign rank for your x? So that when you add that rank, you will get equal to 4? No, right? Only this way. Okay, only the only way is here, 1, 3. Okay, for 1, 5, 1, 5, sorry, 5, 5, we can assign 1, 4, or another one we can assign 2, 3. Yes. Okay. So if 6, we can assign 1, 5, or we can assign 2, 2, 4. And for 7, we can assign
2, 5.
2, 5, or
3, 4.
3, 4.
1, 6.
Okay, or 1, 6. Okay, so we have three ways to assign the rank for our x. Okay, for 8, 9, and 11, no need to find the rank. Okay, we can have the symmetry here. Okay, meaning that 3 is actually, okay, 7 is symmetry. So 6 is actually equal to 8. 5 is equal to 9. Is it correct here? I think 10, okay, 10 and 11, right? Okay, 5 equal to 9, 4 is equal to 10, okay, 3 is equal to 11. Okay, just find the rank here. Okay, the rank for 3 until 7, or if you want to find rank 7 until 11 also can. Okay, which one you prefer? Okay, so maybe for the smaller number of WN is much easier to assign a rank for them. Okay, so here will be your TK. Okay, TK is the number of arrangement. Okay, the number of arrangement, the number of way to assign rank for X and rank for Y, so that when you add the rank for X, it will be equal to your K here. So this is, we have TK here. Okay, we will have equal to 1, here 1, here 2, here 2, and here is 3. Okay, actually for this 2, 2, 1, and 1. Okay, it is symmetry. Okay, and then you can get the property of Wn, which is equal to Wn equal to K, which is equal to Tk divided by Y here. The denominator is equal to capital N M. Okay, so that it is equal to Tk divided by N is 6, M is 2. So here this is actually equal to 15. Okay, so 1, the property of Wn here, when Wn equal to 3, so the property is 1 over 15. Here when Wn equal to 4, 1 over 15. When Wn equal to 5, 2 over 15, and so on. Okay, when you add all this property, it should be equal to 1. Okay, so that is the null distribution of the Wn. Okay. Okay, so test the null hypothesis. Okay, test the null hypothesis. Theta less than or equal to 0 against the alternative theta greater than 0 at alpha equal to 0.3. Okay, at alpha equal to 0.3. Okay. So what is your Wn here? Okay, what is your test statistic? Okay, we have the null hypothesis theta less than or equal to 0. And for the alternative hypothesis, theta is greater than 0. Okay, theta is greater than 0 means that, okay, your Y shift to the right of X. Okay, so that the median of X is actually less than median of Y, right? Okay, this is your X. When theta is positive, means that your Y shift to the right of X. Okay, so we will have the median of X less than median of Y. So the small value of Wn will tend to reject the H none. Okay, small value of Wn, right? Okay, because most of the X most of the X will have a smaller rank. Okay, because the median of X is less than median of Y. Okay, most of the rank for X is small compared to the rank of Y. So that's why the small value of Wn will tend to reject the null hypothesis. Okay, so Wn here, what is your Wn? Okay, first you have to combine these two, right? Okay, Wn, what is the Wn? What is the Wn? Can you give me the answer for Wn? What is Wn? Anyone? How to get this Wn? Wang Jin? Wang Jin? What is your Wn?
Which WM is plus and minus 0.5. This one for formulas.
Your WN, your test statistic value. Where is your test statistic value? Equal to? Here.
6.
6. How come you get
3.
6?
4.6.
3. Yes. 3.
1.3.
3. Okay, first, okay, you need to make it very clear here. Okay, WN is the rank sum for the smaller sample size. Okay, so here we have two sample size, M equal to 2 and N equal to 4. So the smaller sample size is M equal to 2. Okay, the rank sum, actually the rank sum for the sample A, right? Okay, because A consists of 2 observation, sample B consists of the 4 observation. Okay, so you have to combine these two samples together and give them a rank. Okay, so you combine these two, give them a rank. So the rank number 1 will be here, right? Okay, this is rank number 1. Okay, rank number 2. Okay, rank number 3. Rank number 4. Okay, rank number 5, and this one is the rank number 6. Okay, and then you get the rank sum for each sample. So the rank sum for this is 1 plus 2, 3. Okay, the rank sum for B, 4 plus 6 plus 3 plus 5 is equal to 18. Okay, so the test statistic, okay, the test statistic is the rank sum for the smaller sample. Okay, WN is the rank sum. Okay, rank sum for the smaller sample. Okay, I have mentioned this. Mentioned this that okay, before this my lecture notes have a mistake that I put WN as the minimum between the rank sum of rank sum of sample 1 and rank sum of sample B. Okay, that is the mistake, so I already correct them. Okay, so that our test statistic WN is actually the rank sum for the smaller sample. Okay, confused with the mean with me. Okay, mean with me, it will consider the minimum. Okay, between the two sample. Okay, but for the Wilcoxon rank sum, it is the rank sum for the smaller sample. So you have to identify which one is the smaller sample. Okay, smaller sample with the smaller size of observation in that sample. Okay, so that is the WN statistic, and then we have to determine our rejection region. Okay, so we look at here that our rejection region, our alternative hypothesis, theta is greater than 0. Okay, meaning that we have one tail test at the right side. Okay, right tail test. Okay, because theta is greater than 0. Okay. Okay, so we will reject H null if Wn, okay, is greater than or equal to theta. Wait, theta. Okay, not not right side, left side. Okay, we look at here. Okay, mx is less than my. Median of x is less than median of y, means that most of the x will have the smaller rank, okay, compared to the y observation. Okay, can you see that mx less than my means that most of the x observation will have a smaller rank compared to the y observation, so that our rejection region will be at the left tail. Okay, at the left tail. So small value of Wn will reject the null hypothesis. Okay, small value of Wn will reject the null hypothesis. So reject H null if Wn is actually less than or equal to W alpha. Okay, no need to divide alpha by 2 because we only have one tail test here. Okay, so alpha is 0.3. Okay, W 0.3, we have to find from the Wilcoxon sign rank table. Okay, 2 and 4 closest to 0.3. Okay, closest to 0.3 is actually here, right? Oh, 0.3, right? 0.3, 2 and 4. Our sample size is 2 and 4, 0.3 is here. Okay, 5. Okay, so the critical value is actually 5. Okay, so since our Wn is equal to, what is our Wn just now, is equal to 3, right? Okay, is equal to 3, it is less than, okay, W 0.3 equal to 5. So what is your decision? Reject H null. Okay, so we reject H null, and then we can see that most of the X has a reject H null. Then we can see that the median of the X population is smaller compared to the median of the Y population. Okay, is it clear? Anything you want to ask? Maita, okay?
Yes, doctor. It's okay.
Ali, okay?
Yes, doctor.
Okay, Wang Jin?
Yes, doctor. Yes.
Yeah. Okay. Okay, so if that one is okay, find the point estimate and 73. Okay, 73.4% confidence interval for theta. Okay, try to get this one. Okay, the point estimate and 73.4%. Okay. You have to get the differences. Okay, the differences where Dij is equal to Yj minus Xi. Okay, Y minus X. So what is your X? What is your Y? Okay, X will be the smaller sample size. So A will be your X. Okay, and Y will be your B. Okay, so you get that differences. Okay, so we can get the metric here, 4.9. Okay, so 4.9, and then 10.3, 3.4, 5.6, right? Okay, this is your B or your Y. Okay, and this is your A, which has 1.3, 3.3. Okay, this is A is your X. Okay, you get these differences. Okay, Y minus X. So 4.9 minus 1.3 is 3.6, right? 3.6, and then we will have 9, 2.1, okay, 4.3, and then we have 1.6, 7 here, 0.1, and 2.3. And then you sort these differences in increasing order. Okay, so Dij now is, okay, the smallest is 0.1, 1.6, okay, and then 2.1, 2.3, 3.6, 4.3, 7 and 9. Okay. Okay, your theta hat, okay, find the point estimate. Okay, theta hat is actually the median, okay, the median of Dij. Okay, so equal to, okay, we have 8, right? Okay, so even number. So D, okay, D8 divided by 2 plus D8 divided by 2 plus 1, okay. Okay, by 2 plus 1, okay, and divided by 3. Okay, so D4, okay, we have D4 plus D5 divided by 2. Okay, D4, okay, the fourth position 1, 2, 3, 4. Okay, so 2.3. Okay, the value at the fourth position is 2.3, and at the fifth position is 3.6. Okay, divide by 2. This one will give you equal to 2.995. Okay, that is the median of the that is the point estimate of our theta. Okay, point estimate of our theta. And then the confidence interval. Okay, the confidence interval, you need to get K first. K is equal to Wn max. Okay, minus W alpha divided by 2 plus 1. Okay, Wn maximum. What is the Wn max? Wn max, what is Wn max? Equal to?
11.
11. Okay, so 11 minus W alpha divided by 2. Okay, you can get from the Wilcoxon sign rank table. Okay, alpha is equal to, what is your alpha? What is your alpha? Okay, here we use 73.4%. So it means that 1 minus alpha 100% equal to 73.4%. So our 1 minus alpha is actually equal to 0.734. So alpha is actually equal to 0.266, right?
6, yes.
Okay, so alpha divided by 2 is equal to 0.133. Okay, so you have to find the W 0.133 from the Wilcoxon sign rank table. Okay, so from this table, okay, we have 2 and 4. Okay, 0.133 is actually here. Okay, 0.133. So the value is equal to 4. Okay, the value is equal to 4. Okay, so here equal to 4. Okay, this one is equal to 4 plus 1. Okay, 11 minus 4 plus 1 is equal to 8. Okay, so the upper interval, okay, the upper limit for our theta, okay, the upper limit for our theta is equal to dk equal to d8, which is given by 9. Okay, given by 9 here. And how about the lower? Okay, the lower is dmn plus 1 minus k. Okay, so equal to dmn for 2 times 4 is 8 plus 1 9 minus 8 is 1. Okay, d1. Okay, so our d1 is equal to 0.1. Okay, so we will get our theta here. Okay, our theta is actually between 0.1 and 9. Okay, this is 93.4% confidence interval for our theta. Okay, you can see here that our theta hat, okay, theta hat is 2.95, which is included in this interval. And this interval, if we can interpret this interval, it does not contain the value of 0. So there is no possibility that theta equal to 0. So can you see here that by using the confidence interval, you also can make an inference regarding the theta value. Okay. So the theta value is not equal to 0. So there is no possibility that your mx equal to your my. Okay, so the distribution of the x and y, the median of the population x and y are different. Okay. So I think that's all for this topic. Anything you want to ask before we take a break?